This is the imager
Should you take it out?
for image the blot, the Western blot. Basically based on the chemical luminescence. You can put the sample here. So if you have a Western blot, if you have a blot where protein is attached, and you attach antibody, and the antibody probably can, after some enzymatic reaction, give you the bioluminescence. So put it here, and then this camera will actually capture that image. So if the protein is indeed there, then antibody will recognize it, and you'll see a band, a signal coming from that blot. Student desk, we have like 3 graduate students right now. Razor. I have a nano-pure water. This water is, I would say, very pure in terms of there are very small amount of ions in the water, so the resistance is really high. So you don't want to prepare a buffer, but then the water already have some ions in there. So this is a very pure water. Okay, here. The stereo microscope we use for dissection. Remember, I need to kill the rat and then take the neuron out. So this is how you do it. You basically, when you are doing the dissection, you look at the tissue culture here, and then you turn on the light, and the light can give you, it's basically a illumination source. Anyway, we'll not turn on the light today. Another small microscope, just to check a fine structure. For example, this is a smaller, I would say a simple, like a toy version of the microscope, but you can see little structure like our hair. You can easily see it here. Little oven. We make our little microfluid device within this oven using a material called PDMS. Polydimethyl silicon. It's a material that once you heat it, and then that can become a transparent, almost like a plastic device. And I show you some sample device. Okay, so this is what it looks like, and you can feel it. It's like a soft plastic, yeah. And then see, we can cut off things. We can cut off things, and we can make little chambers, and we can make actually very fine structures using this material. Mm-hmm. And then that material we can use it to culture the cell. So this is one of the material that is also very important in our own lab. Okay, next. Yeah, careful about the shower. Okay. We're moving into a so-called cell culture room. So this cell culture room has a typical setting. We'll see. Okay, I'll introduce one by one. This is a cell culture hood, sterilized hood, because especially in doing mammalian cell culture, you don't want the cell culture to be contaminated by bacteria, for example. And there are actually bacteria everywhere, in the air, floating right now. So this is a hood that can actually generate a laminar flow, so to keep the bacteria and contaminant out of the hood. And also have a UV light to sterilize the device inside. So whenever we start to work with mammalian cell culture, we always open the cell culture and all the medium within the hood, and then we close it before we take it out. After you take it out, we put it here. These are the so-called CO2 incubator. Because for mammalian cell, maybe you'll learn in the future, it's different for bacteria. Mammalian cell actually needs a constant supply of CO2. So you can see all the tank connected to the cell culture, to the cell CO2 incubator provide a constant flow of CO2, which is important for gauging the pH value of the cell buffer. We culture the neuron cell, not neuron cell, kind of all type of mammalian cell here. You can take a look. There's another door, a glass door, to make sure everything is still sterilized. And then the little device, those are the tissue culture plate. Then see the medium is actually pink. Pink reddish medium. That's a medium, that's a nutrient for the cell to survive. We'll keep it in this cell incubator. This is another cell incubator. We have it used for different device. Another microscope. So this microscope, we can use it to count how many cells are in your sample. It's also a simple form of stereo microscope. Actually upright microscope, not stereo microscope. Centrifuge, water bath. So we keep it only in this room because again, no bacteria can go into this. Even for the freezer behind you, no bacteria medium can go to that. So we have a special instrument for all the mammalian cell work. Yeah, and also that's why this whole room has a so-called biosafety level 2, which allows us to do even for human cell culture. All right, let's go to the next room. My favorite room. There will be some wires and optics in this room. And then, see?
Yeah, get that shot.
Yeah. And there's also laser, but now laser is off, so
You know
it's
what?
safer.
This would be easier if I could unscrew this real fast. Instead of taking the tripod around, I can... There you go. Okay.
Come on in. The laser is off, so it's safe. But it's a different world, right?
Yeah.
So you can feel, or you can even feel the air is different in this room. Because our department actually spent a lot of time and effort in making the air in this room, making the air clean. Why? Because we have optics exposed to air. Okay, I'll show you, this is a microscope that we built ourselves, of course with a commercial microscope frame. So this microscope actually has the capability of looking at a fluorescent signal from one molecule, so-called single molecule microscopy. Let's start from the laser source. So these two devices are two laser sources. It will generate color of different laser, a different color of laser. Okay, sorry about all these wires, but then we have to make our way into this. So both laser, this one is green, this one is blue, because for some chromophore they need different light to excite them. And actually both light they can combine here, and depending on what color you want to use, you can use a shutter to select which color to use. And they're all directed this way. So this is so-called a telescope. You can expand the beam to a larger size, which is needed for that single molecule microscopy. And the beam keep translating through all the mirrors until it reach the so-called back port of the of the microscope. So this back port will take the light, and then within this microscope, we can go to the other way. So now light is coming from the bottom, and you see this device. This device is a filter cube. So basically, within this filter cube, there's a mirror called dichroic mirror. It's sitting this way. So the light is hitting here, and it will be reflected to the top. The light will be reflecting to the top to reach into the objective, the so-called objective, the eyes of the microscope. And then in reality, when we're doing experiment, we'll have adapter. For example, the sample can be put on the adapter. An adapter can be set here. So now you have an adapter, so you can put your cover slip or cover glass or cover slide onto this adapter. Now you can move it around with this two-dimensional manipulator, the so-called microstage. And then you can turn on different light. For example, from the top, there's a See, there's a power, there's a light source, just to illuminate the sample so you know where the cell is, where your sample is. Okay, after the sample is excited, most of the time we're looking at fluorescence. This is a process that you can excite a molecule to excited states, and then the excited states will decay back to the ground state and emit one photon, meaning the smallest unit of light. So that one photon is a fluorescence photon. How can we detect it? Through the same microscope, because fluorescence actually emits to all the different directions in space. And some of the fluorescence will be actually entering the same objective, going down, passing that filter cube. So remember, there's a mirror here, right? That mirror is so-called the dichroic mirror. It can reflect one color of light, but it actually will pass different color of light. So the fluorescent light, we can choose the setting for the filter, so it can, for example, reflect the blue light and then pass the green light. The fluorescence is green. After it's passed, then it's directed. So within the chamber somewhere here, there's a mirror like this way. To direct all the beam, all the fluorescent light to the left. We can come to this one, this side. There's a camera on the so-called this left port of the microscope. So once fluorescence is coming here, it will be detected by the chip of this camera. And then we can look at the camera. We can look at the image by the microscope. Of course, now everything is off. I didn't really have any live cell image to show you. But you can imagine, if something is moving here within the cell, then light will capture it, and then the camera will record it. And we'll have a live cell movie for how cell moves or how things moved within the cell. So this is one microscope. This one, we bought the microscope frame, but we build all the different optics to get a single molecule sensitivity. And then here, I want to show you a different microscope. This microscope is from a different company. It's more like a full-fledged commercial microscope. Easy to use. The basic setting is very similar. Instead, well, it doesn't use laser, it just uses LED. So all the light power is actually on top. See all these wires, including including this, the so-called light guide. So the light from the LED will be actually transported within this guide and then put into the microscope. See, the light is also coming from the back port of the microscope. And then also within the microscope, there's that filter set to reflect the light up to the objective, and the objective will collect the fluorescence and direct it to the camera. In this case, but then this one is more like a toy. You can just press button and then move and record the image. It's easy to use, but then the sensitivity is not as high. That's why we have both microscopes. See, they're sitting on this so-called optical table. On the table, there are different holes, and these holes are, it's like a Lego basically. We can move different optics. We can set different components with a screw on the hole. So this hole, they have all common thread. On the grain, okay. So this is a very simple way of building the Lego. Whatever thing you want to fix
Okay.
on the table,